Okay, good morning class. Today we're going to look at hexadecimal numbers. So slide number 1 is titled hexadecimal. Do It Now is in a cryptogram worksheet, so it's basically working out what the coded message says. It's attached as a PDF, so feel free to do it. You can either view it in your browser or you can download and print it off if you prefer, whatever. You can either let me know what the message says or show me a picture of you completing it. I don't mind, as per normal. So when you're ready, we're going to go to slide 2. Again, this is a video, so you can pause it, rewind, pause it, whatever, as many times as you want. So today's lesson objectives are to understand the base 16 number system, otherwise known as hexadecimal, and obviously you're going to do some conversions from denary, that's base 10, that's our normal number system, to hexadecimal and back again. The point of the lesson is to understand why we use hexadecimal numbers and also to show you where we use them. So there's a video that's been on Show My Homework listed before this video, so you should have watched this little slide on hexadecimal numbers, so we're going to just skip that one. I presume you've watched it. So what is a hexadecimal number? Base 2 is what's known as binary. We've covered that numerous times in previous lessons. Base 10 is a number system you use every day. Base 16 is known as hexadecimal. As it suggests, there are 16 possible values for each column. We only have 10 digits in our number system, 0 to 9, so we have to use the first 6 letters of the alphabet to cover the rest of it. So hexadecimal is used a lot in computing, especially in graphics and websites. When you represent colours on a website, for example, like I used to do, they're usually stored as a hexadecimal value. It just makes certain that a particular colour is going to appear on the screen. You could put in dark blue, you could put in magenta or red, but sometimes the browsers will view these differently. Using hexadecimal values means it will come out the same colour on every device. So, if we're going to convert it, we're going to do this example of 187. So we put it in the normal binary table first. So 187 in binary is 1011, 1011. The next thing we do is split the 8-bit number into two 4-bit nibbles, as they call it. So it's 1011 and then 1011. So then we do 8 add 2 add 1 gives us 11. And then same again, 8 add 2 add 1 gives us 11. So both of these nibbles add up to 11 in denary. So what we then do is we look up the value 11 on the hexadecimal table, which if you go back or rewind the video, you'll see is the letter B. So we've got B is the value for both of these nibbles in hexadecimal. So therefore 187 in our normal numbers is actually stored as BB in hexadecimal. So your first task is to have a go at these conversions, convert the following denary numbers into hexadecimal for me. If you want to have a little bit of a challenge, go to a website called Color Hexa, combine the first three and the second 3 hexadecimal values together and see what colour they come up with, because it'll be, there's usually a 6-digit value. A hexadecimal colour is like, say white, for example, in hexadecimal is FFFFFF, and black is 000000. So feel free to have a go at that. Like I say, it's a video. You can pause it, rewind it as much as you need to, so you can go back and look at how we worked out 187. And good luck. Task 2 is doing it the other way. So you would need to look up on the table at the top what AA is. So AA will be 1010, and then work out what 10 is in binary. So it'll be 1010 off the top of my head. Again, you can combine the values and have a look on Color Hexa what they make. Take your time, good luck, make sure you somehow show me your work. You can either paste it into a message into Show My Homework or take a picture, I don't mind. And then lastly, just to reiterate, the point of the lesson was to understand base 16 and then how to convert denary into hexadecimal and then why we use it. So we use it just because it makes large numbers much easier to remember, basically. I hope you did okay. Good luck, and I'll speak to you soon.